All righty. Let's do some functions. Last week of functions. All right, so let's make it count, virtual or not. Doesn't matter. Nothing's gonna stop us, right? So function rules from equations. So when we have equations, we have two variables. One variable is called independent, one variable is called dependent. Okay, so in our most famous equation, there are two variables, x and y. X is the indi, and y is the dependent variable. Okay, so one thing I want you to notice about the dependent variable is it's the solved for variable. So if we want to rearrange the equation, so m is the independent variable, that's the not solved for. So everything else is on the side with the independent variable. You know, dependent is by itself. It really, now that I think about it, is opposite of what it should be. You think independent is by itself, but no, it's the opposite. And it's for this reason. The independent is the one that you can choose to substitute in for. Then you got to do all this stuff to it. And the dependent variable is what you end up with, depending on your independent. In any case, let's do some solving. So we got 7m plus 2 equals 7n minus 5. If m is the independent variable, then circle the n, the other one, and just think in your head, get n by itself. That's our goal. We do that, we'll be done. So how are we going to get, well, draw the line, first of all, right? Let's get this, get that 5 over to the other side. Can we do that? Can we move that 5 over? So that's going to go over the line, change the sign, right? So now we got 7m plus 2 plus 5, 7n. All right. N is almost by itself, but we better divide by 7, and then it will be all the way divided. And then now it's by itself. And I can just simplify over here, and I'll have. So 2 plus 7 is 7. You see how I wrote this where I divided the whole side by 7? You can do that, but I think it is a little confusing. I like to write it where I divide the terms separately by 7. Because now 7 divided by 7 cancels out. And then 5/7, we can just leave that as a fraction. And guess what? We just solved for n. So we should be right. Let's give it a go. M plus 5/7. Doggone it. I might have made a mistake. Let's see. 7/7. Oh, you see what I did? I found my mistake. 2 plus 7. But then when I didn't, I'm sorry, guys. I should have put a 7. 7. That's a 7 there. And then 7/7 is 1. All right. Is that a yellow problem? Maybe. All right. Now let's move on to the word problems. Okay, a battery is charged. The percentage of the battery's capacity that is charged as a function of time is graphed. All right. So this is very important because we have been graphing lines, and now we want to actually know how to use the stuff we've been doing. Otherwise, why learn? So when I look at this graph, the first thing I look at is the labels on the axes. So this is a graph about time. So we go from 0 minutes all the way to half an hour. Does everybody see that? And we're talking about a battery being charged. We can all relate to that, right? Okay, so hey, half an hour and it's fully charged. It went from 40% to 100%. So now I'm starting to see the story of this battery. The y-intercept is 40. That means, the y-intercept is the beginning. At 40% is where the situation starts. Plugged it in, and now it's charged. But the question is, what is the rate? So rate is a slope word. Okay, so all we got to do is we've got to find the slope. So I see that we already have the y-intercept, and then also we can use the n, 30, 100. And so all we got to do is find the slope. So we got x is x1, y1, x2, y2. So we'll do 100 minus 40 over 30 minus 0. That is 60 over 30. And that's 2. So every 2 minutes, or the battery charged 2% every minute. So let's see. 2% every minute. Okay, not to be denied that time. You guys want to do another one? How long did it take the water to completely drain? All right, so let's try that same technique here. Oh, Archimedes is filling water. It's tough. Okay, so again, I'm trying to make sense of the situation and just see what I'm actually looking at. So I look right here. Something is happening from 0 minutes to 5 minutes. Water in liters. We're starting out with 360 liters, and by 5 minutes, we have nothing left. And so now I read the question, how long did it take the water to completely drain? And then I'm like, so I didn't even start by reading this. I just started by trying to understand the graph. And now I'm reading it. Oh, there's a tub and it's draining. So how long did it take the water to completely drain? Well, we kind of know that already, don't we? 5 minutes, there's 0 liters left. Was no calculations to do there, just understanding the graph. So look at the units, understand the situation as much as you can from the graph, read the situation itself, and then see, are they asking you for the slope, the y-intercept, the x-intercept, or something else? And the more practice problems you do, the more you'll build your understanding of that. And then we have these word problems without the graph, just with an equation. Let's read from top to bottom this time. We can measure temperature in 2 different common units, degrees Celsius and degrees Fahrenheit. The variable F represents the temperature in degrees Fahrenheit that is equivalent to C, the temperature in degrees Celsius. Stop right there. I noticed that we have our variables. The variable F is degrees Fahrenheit. And then we have another variable, C is degrees Celsius. It's very important to know what your variables are. What is the temperature increase in degrees Fahrenheit that is equivalent to a temperature of 10 in degrees Celsius? So they gave me 10 increase. Okay, so if I substitute but they're saying what is the temperature increase? So they don't want to know the temperature. This equation gives me the temperature. but the slope gives me the rate of change. So if I just multiply these two together, I get 18. And if I were to add the 32, I would get, see, what I did was I substituted in. 18 plus 32 is 50. So this tells me that 10 degrees Celsius is equal to 50 degrees Fahrenheit. But they didn't want me to tell them what is 10 degrees Celsius. They said, what is the temperature increase in degrees Fahrenheit that is equivalent to the temperature increase in 10 degrees Celsius? And the answer to that is 18. 18 degrees Fahrenheit increase is equal to 10 degrees Celsius increase. And then if you add the 32, you get the actual temperature. This is a tough one, but the key is to look for that word increase. And let's just make sure I'm right. So it's 18, and I am right. All right. Okay, so that's enough to get started. And then we're going to be making a list of keywords and organizing the different questions that they ask. And then it'll get easier and easier the more you practice.